The other importance of looking at dimensions is to predict the nature of an equation or to derive a relationship between quantities which are involved in a particular kind of physical phenomenon. That's the other importance of dimensional analysis. I gave you an example in class. Could you suppose you were asked to find the equation for centripetal force, let's say centripetal force, but then you don't know what's the equation of centripetal force, but what you know is the equation of force. That force is mass times acceleration, which is given by mLt to the power -2 in terms of dimensions. Because it's a force, whether it's centripetal or it's a straight line force or it's a weight, the dimensions for force will be always dimensions of force, which is mLt to the power -2. So it doesn't matter whether you're dealing with the centripetal force or you're dealing with the linear force or you're dealing with weight, but the dimensions will be the same. But what will differ will be the formula of just weight or formula for centripetal force. By definition, centripetal force, you are looking at force which is acting in a circular manner. For example, when a truck is moving around in a roundabout, the velocity which this car is incurring is called centripetal. It's a velocity in a circular path, and its acceleration is called centripetal acceleration. So from centripetal acceleration combining with the weight of the object, which is mass of the object, then you can have centripetal force. So centripetal force basically imakhala kuti pali chinthu chozungulira imene obviously muli ndi radius pamene popo. You also have mass amene pamene popo. You have mass, you have the radius, and of course you have the velocity of that particular kind of object imene imapasa an acceleration kumapeto. Now, because you know the variables which are involved in centripetal force, then you can easily find the dimensions and also formula for centripetal force by just looking at those variables, just bringing in a relationship. Now let's look at an example. Let's look at an example of finding centripetal. Or finding a particular kind of formula from a problem. So we have this example. Suppose we are told that acceleration of a moving object is given as v, is given as a, and this object is moving at a uniform speed, which is v, in a circle of radius r. Determine the formula for the centripetal acceleration. Determine formula for centripetal acceleration. Okay, I've just replaced it without putting the values of v to the power n or v or r to the power m. So I just want to make it neutral example, because here we have another example in which we are not guided. Suppose you are doing an experiment to find out composition of velocity of sound through a media. Through the experiment, you find out that the velocity of sound depends on density of a media and the modulus of elasticity. If the dimension for modulus of elasticity is given as those dimensions, deduced by method of dimensional analysis, the formula for velocity of sound through the media, the formula for velocity of sound through the media. So if you look at that particular kind of problem, you are not guided in terms of powers which you need to use, but you have to deliver your own, the powers for each particular kind of variable. So I will rewrite this problem which we want to solve. I will rewrite it so that we shouldn't have the guidance in terms of powers, but we need to solve and find the equation for acceleration. By finding the equation for acceleration, we may find the values of n and m. So I will write the question as follows. Centripetal acceleration is defined as acceleration in a circular path. Suppose we are told that the acceleration A of a particular moving. Suppose we are told that the acceleration of A of a particle moving with a uniform speed, and this uniform speed is given as v in a circle of radius r, suppose we are told that the acceleration of a particle moving with a uniform v suppose acceleration of a particle, suppose the acceleration of a particle is a function of uniform speed v and radius r. Find the equation for centripetal acceleration. Find the equation for centripetal acceleration. Okay, that's the question which we have. Centripetal acceleration is defined as acceleration in circular path. Suppose acceleration A of a particle is a function of uniform speed v and radius r. Find the equation of centripetal acceleration. So I've deleted this particular kind of problem from the above, just to remove the powers, to remove the guidance, because sometimes you may be given a particular kind of problem which doesn't have the guidance, and you need yourself to find out how you are going to solve that problem. Now let's solve. So we are given that acceleration is a function of acceleration is a function of radius and velocity. So velocity and radius. But what we don't know is what is the power of velocity and also what is the power of radius for this acceleration. That's what we don't know. Now we can write the equation in terms of proportionality constants. Naguti acceleration is equal to a constant times the velocity to the power a, because we to the power variable, and we say naguti variable imeneyi ndi n, and also it's a function of r to the power certain variable, and let's say variable imeneyo ndi m. Okay, so we have introduced the powers n and m. You can choose your own letter, but you choose a letter which is different from the variables which you are looking at. So we are saying acceleration is a function of v and r. But what we don't know is the power of v. What is the power of v, and also what is the power of r, to make acceleration, to make that particular kind of function as a formula for acceleration. So you introduce the powers because that's what you want to find out in an equation. The power of a variable ndotani nanga power variable ina nduti amena pange equation yani. So acceleration is a function of v and r. If you write in terms of proportionality, then you have a constant r, constant k, it's equal to v to the power n, r to the power m. Remember, k is a constant, and in terms of dimension analysis, we don't deal with constants directly. Constants timawasiya tikamaona za dimensions. I will not relate the dimensions of a as power kakumaso r pai kakumaso v pai. We know the dimensions of acceleration, the dimension for v, and also dimension for r, which is radius. Now, if I want to write this equation in terms of dimensions, then acceleration, remember, the acceleration is given as L t to the power -2. That's acceleration. And the velocity, remember k, we'll leave it. Velocity is given as Lt to the power -1. That's velocity. Lt to the power -1. But remember, velocity from this formula is raised to the power n. So we raise this velocity to the power n. So we are multiplying with a dimension of r. R is radius, and radius is distance. Distance has a dimension of L. So we have L, but what we don't have is t. Remember, from the previous lessons we said when a function in a dimensional analysis, when you have more than one dimension, you should make sure that the dimension of each and every variable is present formula ili yose. Now pa r apa we don't have t, but we include a dimension of t, but we raise this t to the power of 0 kuti ma dimension yo akhale ofanana. And we said t to the power 0 is 1, and 1 times L you have the same L. Hope we are clear here. Similarly, this r is raised to the power m. R is raised to the power m. So we'll write the dimensions as that.